Hello! This video tutorial is devoted to HSP and LAB working color models in 3D LUT Creator. In the video that was dedicated to the principle of the AB and CL color grids, we discussed the HSL color space, which is very similar to the HSP color space, the basic working color model of the program. So today, I will start with HSP-based color models, especially since one of them, HSPE, is the default color model for the program. Let me remind you that the color model that is loaded by default can be set in the program settings in this drop-down list. The first thing I want to point out is changing the color model affects the AB and CL color grids, as well as the brightness and saturation sliders, and the special curves at the Curves tab. Therefore, while using these tools, when you change the color model, it will affect the final result. The second thing I would like to mention is that after changing the color model, the color grid will not be rebuilt to compensate for the effect of the new color model. The grid's shapes remain the same, but they will be applied to another color space, and the effect will be completely different. So, you should select a suitable color model beforehand. I'll tell you how to do this. So let's consider the HSP-based color models. There are 6 of them. I will show the difference between them using this image. I made it in Photoshop by blending 6 basic colors to a monochrome gradient in the color blend mode. This image can be downloaded from the website 3dlutcreator.com at the Files and LUTs page. Using these gradients, you can now trace how the saturation of different colors changes when the brightness in different color spaces changes. I choose HSP color model and open the CL tab to see how the gradients go in the vertical projection of the 3-dimensional color body. If you watched the video on the principles of the AB and CL color grids, then you already know that on CL grids, the neutral axis is vertical, and the color saturation will increase from the neutrals to the sides of the grids. Using this eyedropper on the CL tab, you can choose which pair of colors the grids go through. Notice how the saturation of different colors depends on the lightness. In the video about the color grids, we used a cylinder as an example of a 3-dimensional model of a working color space. In this case, we have a form that can be compared to a circus tent. That is, by increasing the lightness greater than a certain level, the saturation starts to drop to 0. Let's choose the LAB space for comparison. Here, the saturation maximum is reached only at certain lightness, and with the increasing and decreasing of the lightness, the saturation reduces to 0. The color body in the LAB color space has the form of a top toy. At the AB grid in the LAB color model, the color gradients look like loops. For the precise work with the various color shades of the image, the additional color models with special properties have been created. I choose the HSPN color model. The neutral and less saturated colors in the color models with the index N take more space on the grid. I load the image, which can also be downloaded from the website. You can see how the distribution of less saturated colors changes from one color model to another. Now we select the HSPN color model, and the colors of the second desaturated color wheel are here in this area. I change the color model to the HSP. Less saturated colors are pulled to the center of the grid. It appears that we zoom into the central part of the grid with desaturated colors when we choose the HSPN color model. So if you want to work with desaturated colors, you should choose the HSPN model, as it will be easier to select the right shade. The color models with the E index have an extended distribution for the saturation of very light colors. Let us return to the LAB model, where the color saturation depends on the lightness. On the AB grid in the LAB model, you can confuse desaturated colors with very dark or very light shades. To avoid this, use color models with the letter E at the end. To explain how this works, I try to lighten the shadows and darken the lights with the luminance curve. In these areas, the image becomes gray, because in the LAB model, the dark and light colors lose their saturation. Now I change the model to HSPE. It turns out that in these areas, there is some color and it can be restored. In practice, when we brighten the shadows on the image, you can get gray areas. The same goes for the light colors. If you want to preserve the color, you should use the HSP model. Let's consider the HSP and E model. The main advantage of this color model is that the color saturation is almost entirely independent of lightness. Color gradients on the AB grid turn to dots, and on the CL grid they look like columns. That is, the saturation remains a constant over the entire range of lightness. How can we use it in practice? For example, you want to repaint the red gradient in a different color. That is, you need to change the red hue of the entire range of brightness. As an example of a red gradient, I use this photo of a red car. In the LAB color model, the color of the car takes a lot of space on the AB grid because we have the red hue in the shadows and highlights. This can be seen on the CL grids. Here is the red in the shadows. Here it is on the image. Here are the light red shades where the car body has a glare. To repaint the car in the LAB model, you need to select the whole sector. In the HSP NE model, it takes only a small area on the grid, and by moving only several points, you can change the color of the car in the entire range of brightness. Thus, using HSP NE model, you can easily repaint objects whose colors have a huge range of brightness. In addition to these color models, there is the HSP3 model that has a wide distribution on the AB grid of red, green, and blue colors. If these colors prevail in your image, you can choose this model. The last HSP model is HSP ITN. In this color model, the colors on the AB grid are arranged similarly to the ITN color wheel. This was done in order to simplify the making of color harmonies on your images. If you are unsure which group of color models, the HSP or the LAB, to use, here's a tip. The LAB model is well suited for saturated colors. If you load into the program a desaturated image, it takes very little space on the AB grid, so it will be uncomfortable to work with individual hues. Even if you choose the LAB space with the extended areas of neutrals, the image on the color plane will still take less space than if we choose the HSPN model. However, if you need to greatly change the saturation and hue, or you want to work initially with saturated colors, I recommend using the LAB model. That's all. Subscribe to the channel. Put likes if this video was useful to you. See you in the next video.